Hey everybody, this is Mr. Ainsworth, and we're going to get into a new lesson, 7-8, if you're with me in my class, on how to change a quadratic function from standard to vertex form. So what we're going to do is we're going to take a look at the original parent function first, y equals x squared, and compare it to y equals 2x squared to help us graph the next function, its offspring, y equals 2x squared plus 12x plus 20. As you notice right here, the leading coefficient here of 2x squared is 2. Leading coefficient here is 2. So these two functions are going to have the same shape. It's just going to be shifted around the plane. So the question is, what does the 2 do to the original parent values? Okay, so let's get to it here and see how it goes. We're going to take a domain. Whoa. Okay, that was kind of unique right there. Let me get this going again. So we're going to take a domain from -3 to 3 like we typically do. Remember, the domain is a set of x values. So from -3 to +3, and we're going to check them out. We've done this multiple times in the past. So we're going to square each one of these. Y equals x squared. This is our original parent. When you take -3 and you square it, you get 9. -2 squared, you get 4. -1 squared, you get 1. 0 squared is obviously 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Okay, what is the lead coefficient here? Now a is 2. So right away I know it goes up because it's positive. Okay, it opens up because it's positive. However, is it the same shape as y equals x squared? I don't know. Let's find out. So let's take the same domain, -3, -2, -1, 0, 1, 2, and 3. Let's substitute them in. So 2 times -3 squared. So -3 squared is 9 times 2, 18. Oh, it doubles the values. Look at that. Instead of going left 3 up 9, we go left 3 up 18, twice as high. It doubles the height. That's what it does. It doubles the height, or doubles the y value. Doubles y value. That's what times 2 means, right? Doubles. So 2 times -2 squared. Well, 4 times 2 is 8. So instead of going left 2 up 4, I go left 2 up 8. Twice the height. That's what the 2 does. It goes up, but twice the height. 2 times -1 squared. -1 squared is 1 times 2 is 2. So instead of going left 1 up 1, we go left 1 up 2, twice as high. 2 times 0 squared, 0. Origin still the vertex. Okay. 2 times 1 squared, 2. So instead of going right 1 up 1, I go right 1 up 2, twice as high. Because that's what the 2 represents, twice as high. So 2 times 2 squared. 2 squared is 4, times 2 is 8. So instead of going right 2 up 4, we go right 2 up 8. 2 times 3 squared. 3 squared is 9 times 2, 18. So instead of going right 3 up 9, we're going to go right 3 up twice as high, which is 18. As I've said before, the original parent, we go left 3 up 9, left 2 up 4, left 1 up 1. Now we're going to go left 3 up 18, left 2 up 8, twice as high. All right, left 1 up 2, twice as high. Instead of going right 1 up 1, we're going to go right 1 up twice as high because that's what the 2 effect is. All right, 2 times something is twice the high. Instead of going right 2 up 4, we're going to go right 2 up 8. Instead of going right 3 up 9, all right, we're going to go right 3 up 18. Okay, that's what I'm talking about. So on the left side of the parabola, let's go right 3 up 18. We're off the grid. So let's graph the second point. Left 2 up 8. Left 2 up 8. 2, 4, 6, 8. Right here. Left 1 up 2. And then 0, 0. On the right side, right 1 up 2. Just use symmetry if you want. Just reflect. And then right 2 up 8. Right 2 up 2, 4, 6, 8. Okay, use symmetry if you want. Go ahead and graph your parabola. And if you want to use your trace paper like you have, like if you're with me in class here, you can see that this does not overlap the parent function y equals x squared. This is more narrow. So it's more narrow, as I said in prior lessons, than x squared. Why? Because the y values are twice as high. For one value or one unit change to the right, it goes up twice as high. So it's more narrow or steeper because of the 2. All right, I've talked about that in lesson, I think it's lesson 7.4. If you can take that out, you can take a look how A affects the graph. If A gets larger, all right, it becomes more narrow. All right, so we're going to double the parent values. So now my parent values for this one are twice as large because of the 2. And you already have these memorized. Okay, you already have those memorized. Now all you have to do is understand that 2 makes them twice, the y value is twice as large. Instead of right 1 up 1, we go right 1 up 2. Instead of right 2 up 4, you go right 2 up 8. Instead of right 3 up 9, you go right 3 up 18, twice as high. So if you have these memorized on the left already with a parent, then 2 times the parent is just twice as high. No big deal. So this right here, this new function here, a is equal to 2, so it has the same shape as the new parent function, y equals 2x squared. And if you understand that, then graphing this one in vertex form will be easy. All right, so the question is how do you get from standard to vertex? We want to convert it to vertex form like we did in the former lesson here, which is y equals a times x minus h, quantity squared plus k. Got to go from standard to vertex. Okay, so here we go. We're going to do something similar to what you saw in our previous lesson. We're going to take our function here and get this constant 20 on the other side. So let me repeat the function over here so big and bold so you can see it. All right, so we'll get your red pen out and let's subtract 20 and let's bring the constant on the right. Excuse me, on the left. So we got y minus 20 here plus blank equals 2x squared plus 12x plus blank, right? But you got to remember what I said earlier. You can't complete the square unless the lead coefficient's 1. Let me put that in red, okay? You cannot complete the square okay, unless the lead coefficient's 1. So unless, let me spell that correctly, unless the lead coefficient equals 1. All right, very, very important concept. And right now, let me highlight it. It's not 1, it's 2. So you got to factor out the 2, just like I did in the previous lesson. So y minus 20 plus blank equals 2 times the quantity x plus, excuse me, x squared plus, let me see, 2 times 6 is 12, so there's got to be 6x here, plus blank. Now the coefficient of x squared is 1. I factored it out. Now the lead coefficient is 1. I complete the square, so I take b. I always take b divided by 2 and square it to complete the square. Okay, if I go too fast, you know there's a video, right? So go ahead and pause it. Keep up with the notes and everything. So I got to take my 6 and divide it by 2 and square it. So 6 divided by 2 squared is 3 squared, or 9, and that's the number you add to both sides. Well, you got to be careful with that, right? As I said earlier. So we want to add 9 to here to make it factorable right here in this trinomial right here. But did we really add 9? Okay, so stop. Look, guys. Don't work ahead. Look very carefully. This 9 right here is affected by the 2. It's actually being multiplied by the 2. So look in blue. All right, it's being multiplied by the 2. And since 2 times 9 is 18, let me go put 18 right here. We really added 18 on the right. Okay, so you got to be smart about this. You put down plus 9 to make it factorable, but you got to remember that it's being affected by the 2. 2 times 19, times 9 is 18. So we really added 18. So I've got to add 18 here. It's got to be balanced because you got to add the same amount to both sides. So even though I completed the square and got 9, and I added 9 on the right, I really added 18 total because the 9's being affected by the 2. 2 times 9 is 18, so you add 18 on both sides. All right, now let's finish. 18 minus 20 is negative 2, so you have y minus 2 is equal to 2 times a bunch of stuff, and this is where you factor. What two numbers multiply to 9 and add a 6? What two numbers multiply to 9 and add to 6? Well, 3 times 3 is 9, and 3 plus 3 is 6. So we're going to split the middle term. 3x plus 3x is 6x. So I'm going to split the middle term. Look right here. I just split it right there. And I'm going to add the 9, bring down the 9. Now I'm going to do some factor by grouping. So I factor out the x out of the first group and the 3 out of the second group. So x times x plus 3. Factor out a 3 here, so 3 times x plus 3 again. Okay, my common binomial is x plus 3, so I factor that out. So I get y minus 2 equals 2 times, all right, x plus 3 times the remaining terms, x plus 3. Oh my god, they're the same again. All right, this happens all the time, guys. All right, so what we're going to do is just rewrite this as x plus 3 to the second power. If you want to drop the outside parentheses, the second set of brackets here, go for it. So y minus 2 equals 2 times one of the binomials squared, right here. And then all I have to do is add 2 here and here. And I get y equals 2 times x plus 3 squared plus 2. And what's cool is that now we were in vertex form. All right, y equals a times x plus, x minus h squared plus k. So I already can tell, look right here, a is 2. So it acts just like the parent above. It looks like this guy right up here that we just graphed. It has the same lead coefficient. So we use the same parent values here. Write 1 up 2, write 2 up to 8, write 3 up 18. Okay, the same parent values. And then, what's the vertex? Well, I know that x minus a negative 3 is the same thing as x plus 3. So my vertex is negative 3 comma. Here, obviously, k is 2. So remember, it's always h comma k. So you find the vertex and you look at a. A is 2, so you got to double the y values. I also know that it opens up because it's positive. So it looks like this, okay? So you start graphing here at negative 3 comma 2. So left 3, 1, 2, 3, up 2. At negative 3 comma 2. Draw your line of symmetry to help you graph. Immediately, you always do that first, right? Okay, the axis symmetry is x equals negative 2. Why? Because, not negative 2, negative 3, Goes through negative 3, right? Here's negative 3. Let's see. Vertex, we already know it's negative 3 comma 2. It's a, well, we'll find this out. Let me see. Well, it opens up, so it's a minimum, right? So it's a minimum. So let's use the parent values. What are the parent values? Well, they're right here. It behaves just like y equals 2x squared because the lead coefficient's 2. So instead of going right 1 up 1, we're going to go right 1 up 2. Right 2, instead of going right 2 up 4, we're going to go right 2 up 8. Instead of going right 3 up 9, we're going to go right 3 up 18. So here we go. Here we go. Right 1 up 2. Instead of going right 2 up 4, we're going to go right 2 up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then reflect. Reflect here. And then reflect here. And then draw your curve. That's all you do. And try to draw a nice, smooth, parabolic curve. Okay, once again, right 1 up 2. And then right 2 up 8. Okay, right 2 up 8. That's the second parent values. This one, when the lead coefficient's 2, you got to double these y values. All right, we're going to go right 1 up 2, right 2 up 8, because that's how the 2 affects. And that's all there is to it here. You got to learn how to complete the square and factor, get it in vertex form, state the vertex here, understand what a is. A is right here, a is 2. And that tells me that all the parent values are doubled, all right, and it opens up because it's positive. Now remember, the domain is always a set of reals for parabolas that open up and down. The range, because it's a minimum here, here's the min y value. Okay, so the min y value equals 2. That's the lowest point, 2. Everything else is above it. So y is greater than or equal to 2. And we already stated the rest. And that's all there is to it, guys. Well, there's a little bit more, so let's check it out. Now, when the lead coefficient's negative, what do? Well, you learn from this parent. We know that when a is negative right here, a is negative 3, I can already tell ahead of time that it opens down, not up. All right, but what does the 3 do? So let's learn from the previous and let's figure this out. So let's figure out a domain. Let's figure out, you know what, I'm going to do this. I'm going to do the parent function first, y equals x squared. I forgot to modify this. And then I'm going to do y equals negative 3x squared right next to it so you can see the effects, just like I did before. So first of all, we're going to graph y equals x squared, or do the table for y equals x squared. Excuse me, negative x squared. There we go. Negative x squared, and then I'll do negative 3x squared in a minute. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. Here we go. So negative of negative 3 squared is negative 9. Why is that? Square the negative 3 to get 9, then make it negative. Negative 9. Negative of negative 2 squared. You square the negative 2 to get 4, then make it negative. Okay, negative of negative 1 squared. You square the negative 1 to get 1, then make it negative. Negative 0 squared is 0. Negative 1 squared is negative 1, because you square the 1, then make it negative. Negative 2 squared is negative 4, because you square the 2 and not the negative. And then, so square the 2 to get 4, and then make it negative. And then negative 3 squared is negative 9. Now over here, let's work on this one. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. And now let's multiply all the function values by negative 3. So here we go. Negative 3 times negative 3 squared. Square the negative 3 to get 9, times negative 3 is negative 27. Holy cow, look at that. All the y values are multiplied by negative 3. So it's going to go down, but even farther. Okay, negative 3 times negative 2 squared. Negative 2 squared is 4, times negative 3 is negative 12. So instead of going left 2 down 4, we're going to go left 2 down 12, because it's 3 times the distance downward. Negative 3 times negative 1 squared equals 1 times negative 3, or negative 3. So instead of going left 1 down 1, we're going to go left 1 down 3. Negative 3 times 0 squared, 0. Negative 3 times 1 squared, negative 3. So instead of going right 1 down 1, we're going to go right 1 down 3. 3 times as far because of the 3 there. Negative 3 times 2 squared. 2 squared is 4, times negative 3 is 12. Excuse me, negative 12. So instead of going right 2 down 4, you're going to go right 2 down 12, 3 times the distance because of the 3. The negative just means down. And then negative 3 times 3 squared is 9 times 3 is negative 27. So instead of going right 3 down 9, we're going to go right 3 down 3 times as far, negative 27. Okay, so let's learn. All right, so let's graph. We're going to go left 3 down 27, can't do it. Left 2 down 12, we can do that. Left 2 down 12, that's negative 12. Left 1 down 3, 0, 0. And then using symmetry, there we go. Very narrow graph because because of the 3. The negative means it goes down, and then the negative means that it opens down. And then of course the 3 makes it gets really narrow, so it's very narrow. Okay, C lesson 7-4, and you can check out what we talked about then to make sense of this. Okay, now look right here. Lead coefficient's negative 3. So it has the same shape as this. So what we're going to do is we're going to go left 2, down 12, left 1, down 3, and then we're going to go right 1, down 3, right 2, down 12. Okay? Because it has the same shape. If it has the same lead coefficient, this is called the lead coefficient, well then it has the same shape. So the only thing you guys have to figure out is how to get this in vertex form. Y equals a times x minus h squared plus k. It's called vertex form. So let's go through it. I'll try to go slow, and let's work it out in detail. Here we go. Remember, this is a video, so if you need to pause and play, go for it. So the very first thing we do is we get the constant on the other side. So y equals negative 3x squared plus 24x minus 47. I'm going to add 47 to get the constant on the left. So I have y plus 47 is equal to negative 3x squared plus 24x. Now, remember what I said earlier. Let's go back. It says you cannot complete the square unless the lead coefficient's 1. Well, look right here. It's not 1, it's negative 3, so you got to factor that out. Okay, so here we go. So we're going to have y plus 47 plus blank equals negative 3 times x squared minus now, because a negative times a negative is a positive. Negative 3 times negative 8 is 24, so this is 8x here, plus blank. So what we have is the following here. We got to take a look at B, and we have to complete the square on this to make it factorable, and then figure out what we add to both sides. So let's do it over here off to the side. B divided by 2 quantity squared to complete the square. Our B is negative 8, so negative 8 divided by 2 is negative 4. You can square that, you get 16. So I'm going to put a 16 here, but you got to stop and think, just like last lesson. So let me go back. When we added the 9 on the second example here, we really didn't add 9. We added 2 times 9, which is 18. That's why we added the 18 on the left. Okay, so we got to think about what we're doing here. So did we really add 16? I don't think so, because negative 3 times negative, or excuse me, negative 3 times 16 is negative 48. So we really added negative 48 to the right side. So I got to add negative 48 here on the left side. Remember, it's the same amount on both sides. It's got to be balanced. So one more time. You complete the square first, put the number down. But you got to think, this number here is affected by the negative 3. Negative 3 times 16 is negative 48. So in reality here that we really added a negative 48 on the right. So add the same amount on the left. You got to be balanced. So now let's simplify. 47 negative 48 is negative 1. So we have y minus 1 is equal to negative 3 times all of this. So what two numbers multiply to 16 and add to a negative 8? Okay, well, how about negative 4? Negative 4 is positive 16. Negative 4 plus negative 4 is negative 8. It happens to be this number here every single time. This number is always this number here. It's half the middle coefficient. It's always going to be that way. So we're going to have x squared. I'm going to split the middle term into negative 4x and negative 4x. They combine to a negative 8x. So we split the middle term right here, and then we bring down the plus 16. Then out of the first group, and here's the second group, we're going to factor by grouping. So we have y minus 1 is equal to negative 3 times x minus 4. Here the third term is negative, so factor out a negative 4, and then multiply it by an x minus 4 again. Why? A negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. Then finish your factoring. Factor out the common binomial. So you have y minus 1 equals negative 3 times x minus 4, times the remaining factors, x minus 4. And then combine the binomials. So we have y minus 1 equals negative 3 times 1 of the binomial squared. And the only thing you have to do now is add 1. And you get y is equal to negative 3 times the quantity x minus 4 squared plus 1. Now what you need to do is understand the following, okay? A is 3. So since A equals 3, it looks just like the parent above. Look at this. Negative 3 lead coefficient. So it acts like this parent right here. It opens down and is narrow. Then the next thing, so let me write down opens down here. Opens down. It's the very first thing I recognize. Look at that. H is here, K is here. So it's always x minus h, so h has to be 4. So it's 4 comma 1. For the vertex, opens down, and the y values are tripled, okay, because you got to multiply them by 3. So let's graph 4 comma 1. Right 4 up 1. There's your vertex. Start your line of symmetry immediately. Axis symmetry goes through 4. Let's look at the x-axis. There's 4 right there. So the x-axis symmetry is x equals 4. Vertex is 4 comma 1. It opens down, so we have a max. Okay. Range all reals. We know it's a max y value of 1, so I already can see that the y values are going to be less than or equal to 1, even before I graph. Okay, now we use we triple the y values. So instead of going right 1 down 1, we're going to go right 1 down 3. Right 1 down 3 and then reflect. Instead of going right 2 down 4, I go right 2 down 12, 3 times as far down. That's kind of far. That's why I changed the graph. Right 2, 1, 2, right down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then reflect. Whoops. Now draw the graph. There we go. So it has the same shape as the previous one. Okay, so look at this right here. These two graphs, you can take trace paper and overlap negative 3x squared and overlap this other one. The only thing that's happened is that the vertex up here at 0, 0 has been shifted 4 units to the right and 1 unit up. That's what these other numbers do. It shifts the vertex. It has the same shape because the lead coefficient negative 3 is the same. But the vertex has been moved from 0, 0, 4 units right, 1 unit up. It's been shifted. Fancy name for that is called a translation. Okay? And that's all you have to do. Well, you got to practice now, okay? Because it's one thing watching doing it with me, it's another thing doing it on your own. So the best thing you could do now is your classwork and your homework. All right? And remember, it's a video. So if you need to hear this again after you take notes, the best idea is to rewind it right now and listen to it again. Second time is always easier than the first, I can guarantee it, especially on this tricky stuff right up here in blue. All right, the amount that you add to both sides. Okay, so do your best, do your homework, and I'll see you in my next lesson. This is Mr. Ainsworth. I'll see you tomorrow.